don't know why most of you would be going ahead copying from previous sets, all right? Most of you have this in your phones, PDF format of all experiment that has been conducted. Like, it doesn't make any sense. And some of them are actually wrong. And the marking scheme changes in the sense that you would not find the exact marking scheme for your own experiment. So why do you go ahead copy from previous sets? Like, I've seen most of you reporting gibberish, like it doesn't even make any sense. So I'm only going to shed light on how you should report your experiment, like this sodium fusion test. And that is how you're supposed to be reporting all your manuals, all the experiments in your manuals. So basically, you were supposed to have conducted a sodium fusion test where sodium was fused with an unknown organic compound, right? So you prepared this sodium fusion extract, okay? And then you were supposed to take the sodium fusion extract and test them with some reagents to determine if nitrogen or sulfur or any of the halogens are present. And you know, definitely the halogens we're talking about here is chlorine, the bromide ion, the fluoride ion, right? So that's basically it. Like, nitrogen will give you an observation, sulfur will give you an observation, chlorine will give you an observation. And you can't have this and this in one sample test. Some of you went ahead reporting chloride and bromide ion present. How? Or you just write halogen present. How? Which of the halogens are present? You have to state categorically the actual halogen that is present. Is it chlorine? Yes, you write chlorine is the actual halogen present. Not just writing halogen present. So which of the halogens? When you have an observation that tells you, okay, chlorine will form a white precipitate, bromide ion will form a pale yellow precipitate, and then you have the fluoride ion, which will usually form a yellow precipitate. So a pale yellow, white precipitate, and yellow precipitate, they are all different. Like, they're all different. So you can observe a white precipitate and let's say a pale yellow precipitate at the same time. You see, that is why you're getting it wrong. You can't just have halogen present. You have to state which of the halogens based on your observation. Now, if you look at the first column in your experiment where you are supposed to report, we have something like, what was it? Let me wipe this off. You are supposed to have the sodium fusion extract. Now I'm going to abbreviate that, sodium fusion extract. And you're supposed to add it with the iron sulfate, right? And you're supposed to, shake, all right? But before you shake, you need to heat. So I'm using this triangle to symbolize heating. Then you have to shake, okay? And then you add dilute sulfuric acid, all right? So basically, just report your observation, your inference, right? So how do you just report your observation? What are you seeing with your eyes? Okay, you're observing qualitatively. This is a qualitative analysis. There is no you're not measuring quantities. Okay, that is why it's qualitative, based on visual perception, right? You're not looking at maybe 20 mil, all of those quantitative variables and all of that. Okay, this is based on what you are observing. Once you've added all of this, what did you see? What color did you see? Was there an evolution of any gas? If there's not, okay, what color? All right. If you get to observe that the system, that is the test tube, maybe you'll be given, and then maybe you saw something like a blue color, all right, or you saw something like greenish color, that tells you that nitrogen is present. But you can't just write, most of you, I saw you guys writing bluish or greenish coloration formed. No. Why would you have blue or green? It has to be one color that you observed. You cannot observe two different colors at the same time. All right? So it has to be blue precipitate formed, or blue coloration observed or formed, or greenish, whichever be the color. In as much as it is either blue or green, then the inference, that is the deduction. The inference means what you deduced from the observation. And if you look at your manual, you get to see this observation and inferences. They are all there. You have your answers are in your procedures. So you can just write, if it's that, then you should know that it should be nitrogen. So you just write nitrogen present. You see? Then if you go to the next one where you are supposed to, is it add, what did you even add? Lead acetate. We had the sodium fusion extract. Then you added dilute acetic acid. All right? Then you now added lead acetate, right? So you added these three reagents. So what did you observe? You have to add everything, then you observe what is happening. Is there a color? Okay, what color is that? And usually each time you see this lead acetate being added and all of that, you could actually, I don't know what you saw, but if you saw something like a black precipitate, you write black precipitate formed. If that is what you observed, then if you go back to your procedure, you get to see that wherever a black precipitate is formed, it is attributed to a particular ion. So what is responsible? All right? What would form a black precipitate when the organic compound, we don't know what that organic compound contains, but whatever that organic compound contains, once it's added to these two reagents and a black precipitate is formed, then you should know that sulfur ion is present, or you write presence of sulfur, sulfide ion present, or sulfur present. Either of those two, that is characteristic of sulfur. It forms black precipitate with lead acetate solution and dilute acetic acid. So you see, you just go your way, not copying from previous sets and you think you're getting it right. No. So, and the final one, I guess that has to do with, sodium fusion test. We want to know nitrogen. We need to know if sulfur is present in the organic compound, because basically sodium fusion test converts an organic compound into an inorganic species, such that it converts the ions present them into ionic species that can be determined by qualitative analysis, by ionic tests. Okay, so that is just what sodium fusion test is about. So then nitrogen, sulfur, we've accounted for that, what you're supposed to observe. Then we have the halogens, and I said earlier, chloride ion is a halogen, bromide ion is a halogen, and fluoride ion is a halogen. This gives you a white precipitate. Is the only halogen that will give you a white precipitate. All right, this gives you a pale yellow precipitate. All right, the white precipitate of chloride ion is soluble in aqueous ammonia. All right, this fluoride ion gives you a yellow precipitate, not pale yellow. All right, so it can either be this, or this present in the organic compound. And if you go close and you look at your table, you would get to see that the sodium fusion extract again, because once you've prepared the sodium fusion extract, you divide it into several portions for each of these tests, for each of those tests, right? Nitrogen, sulfur, or the halogen. So you have sodium fusion extract, then you added sulfuric acid, okay? Just symbolizing that way. So then you added nitric acid, all right? You added nitric acid. This is coming from the nitrate, okay? Then you added heat. You heated it, and then you added silver nitrate. Basically,
each time silver nitrate is used in qualitative analysis, you just have it at the back of your mind that you are about testing for the presence of chloride ion.
And chloride ion, chlorine forms white precipitate with silver nitrate. But this silver nitrate tells you that already, if you go through your procedure, you will get to even, okay, this is probably, chlorine could be there. And if chlorine is there, you look at your procedure, what color is it? What color did you observe? Some of you are writing thick white precipitate. Okay, fine. You are trying to describe, okay? But you could just write white precipitate formed. All right? That's all. That is your observation. White precipitate was formed. Not writing something else I'm just seeing all around. Please, you guys should stop making all these mistakes. So, and then what is going to be your inference? Chloride ion gives you white precipitate. Bromide ion gives you pale yellow. Fluoride ion gives you yellow. So this cannot be chloride or bromine ion present. Some of you were writing this, which is not right. And some of you were like writing halogen present. This is not right. Yes, I know chlorine is a halogen, but which of the halogens, which of them, you have to state if it is chloride, bromine, by their color. This is white precipitate. So if it is white precipitate, then that means this is chloride ion present. All right. If it is pale yellow precipitate you observed, if it was pale yellow precipitate you observed, that means this is what? Bromide ion present. If it is yellow, that means this is what? Fluoride ion present. It's as simple as that. You don't have to report halogen present, or you say bromide or this present. No. You should always go through your manual and see the procedure to report accurately. All right. Then if you look closely towards the end of, don't mind my handwriting, I just wanted to make it this way because you guys, I don't know what's wrong with you guys here. So then if you look at the last row where you were told that at the above solution, which solution? The previous one where you were trying to determine if a halogen was present, chloride, bromine, or fluoride. Okay, so the above solution, you are expected to add aqueous ammonia, right? So essentially, why are you adding this? This is going to test for solubility. You want to test the halogen that is actually soluble in this. All right, if you go through your manual, you even get to see that these things are there. All right. For example, the chloride ion, okay, forms white precipitate, which we've said, and it is readily soluble in aqueous ammonia. If, for example, you reported chloride ion and you added this and the precipitate dissolved and like that, so that means it's soluble. So you could just write, okay, since you're sure that it's a chloride ion, you could just write white precipitate soluble in aqueous ammonia. You see? And that is all. So which ion forms a white precipitate and that ion is soluble in aqueous ammonia? You go through your manual. Okay, fine. That is probably chlorine. Then you write chloride ion confirmed. And it is a confirmatory test. It is no longer a thing of if it is present or not, because the previous test you carried out told you that chloride ion is present. So this solubility test is telling you that yes, it is actually chloride ion. So it is confirmed. You see? So, but if you probably had, let's say, a pale yellow precipitate in the previous one, and it was slightly soluble, let's say it was slightly soluble, because pale yellow precipitate is due to the bromide ion, and it is not readily soluble, it's slightly soluble. That tells you that bromide ion, which is a halogen, because you have to be specific, bromide ion is confirmed. That goes to if it was a fluoride ion that was there. All right. And fluoride ion is insoluble. If you observe a yellow precipitate formed, insoluble in aqueous ammonia, fluoride ion is confirmed. If that was what you observed in the previous one, in the above solution. All right. So this is basically how you answer some of this. This is how you report. Don't go about copying. Most of you just come with your phones and then you have all this PDF in your phones, you're just copying. You don't even know if they were right. And even if they were right, and probably the marker could not actually mark very well, and this time the marking scheme changed, then you're in trouble. You see? So basically, this is how you report this experiment. Please, you guys should just desist from making all these mistakes because it could cost you one day. All right?